This is a review of some of the angle theorems that you should remember from grade 8. First of all, a supplementary angle, or supplementary angles, I should say, these are angles that just add together to equal 180 degrees. So the way I remember this is I have a straight line here. So here's my nice straight line. On a straight line, that total has to be 180 degrees. So I have this little line that's breaking that into two parts. So let's call this piece angle X and this part angle Y. What this supplementary angle theorem says is the angles on a straight line have to add to 180 degrees. Okay, so that means that X plus Y equals 180 degrees. And we could divide that up into several different angles. Maybe I would have a third one here. I could call that Z. And in that case, X plus Y plus Z would have to add to 180 degrees. Okay, so angles on a straight line add to 180. Key idea. So use that then to help you find angle M on the example. Okay, our second theorem that we should know is what complementary angles are. Complementary angles are just angles that add together to create 90 degrees. So in this corner here, we've got the box or the little square, and that little square is indicating that C to D to A, actually I think that's a letter O, COA, that makes a 90-degree angle. Now that's been broken into two pieces here. We'll call this one X and we'll call this one Y. So this piece is X, this piece is Y. What this means is X plus Y add to 90 degrees. Okay, complementary angles are just angles that add to 90 degrees. Use that then to help you find angle Y. The third angle theorem that you should remember from last year is if you have two straight lines, so I've got my CD, which was supposed to be straight, and BA or AB, which again is supposed to be straight, if those two straight lines intersect each other or cross each other, the angles opposite to one another are equal to each other. So that means this angle here, which is COA, which I could call little letter A, for example, that angle would be equivalent to the one opposite to it on the crosshairs. Okay, so this would also be angle A. And I could call this one over here, this piece, angle B. Note A and B are supplementary to each other. They would add to be 180. But that also means that the one across from it, or opposite to it, it's equal to B as well. It's equivalent. So opposite angles are equal to each other. Use that property to help you find angle X in the example diagram. Okay, so hopefully you've got the three answers for this, and we'll slide over to the next slide. So the fourth thing that you should know, and we've already used this one earlier in the course, is the sum of the angles, the inside angles of a triangle, they have to add up to be 180 degrees. So if I call this X, if I call this one X and this one Y and this one Z, I know that X plus Y plus Z have to add up to be 180 degrees. You can use that property in the example to help you find angle W. Another thing that you should know from grade 8 is what an isosceles triangle is, and even before grade 8, these little hash marks on the triangle indicate that these two sides have an equal length. So side AB is equivalent to the side length AC. What this means in terms of angles is that the angles across from the equal side, so this angle here, which we could call X, and this angle across from that equal side, which I could call also X, I can call them both X because they're equal to each other. So angles across from equal sides in an isosceles triangle will be equivalent to each other. Use that property along with another one to help you find angle Z in the example. The next theorem that you may or may not know from grade 8 is the equilateral triangle theorem. An equilateral triangle has all three sides equivalent in length. So if I think about that in terms of an isosceles triangle theorem, if I look at this side AB and the side BC, I know that the angle down here, which I'll label X, would be equivalent to the angle in this corner, which would be X. Then if I turn the diagram and I look at BC being equal to AC, I know that my angle X in the bottom corner here would have to also be equal to this angle X by the isosceles triangle theorem. This means that all three angles in an equilateral triangle equal each other, and if they have to add to 180 degrees, I could take that 180 degrees and divide it into three equal parts, and we get 60 degrees. In fact, that will always be true with equilateral triangles. The angles inside will all be equal to each other, and they're all going to equal 60 degrees. So you can use that theorem here to help you find angle Y. The seventh theorem that we have here is called the exterior angle theorem. Now, you can manage without actually knowing this theorem, but sometimes it is handy. What the exterior angle theorem says is if we have the exterior angle to a triangle, so if one of the sides is extended past the triangle, the angle on the outside of the triangle here, let me call that Z for example, that is equivalent to taking the sum of the two interior opposite angles. So not this one here, not the one at angle B. So I'm going to undo that there. It's actually, if I take this angle interior here and this angle, they will add together to give you a Z. Now, that logically flows. We can actually figure that out by, if we know, let's call this X and this one Y. If we know X and Y, I could figure out this angle by the angles sum of the triangle. I know they have to add to 180. I could solve that. And then I could use the fact that I have a straight line here and subtract the angle I found here from 180 to get angle Z. So you actually can live without this one by knowing some other theorems. But what this says here is that angle Z is equivalent to angle X plus angle Y. Okay, and that's a shortcut you can use if you remember it. So use that theorem, to help you find angle X, which is interior to the triangle, inside the triangle. We're going to skip what I have on the page here for theorems 8, 9, and 10. We're going to talk about those ones because those are new to grade 9. But I do want to go on to 11, 12, and 13 on my next slide. These last three theorems all have to do with parallel lines. So the first one is the corresponding angles. This is the one that says if you have parallel lines, which I do here, AB is parallel, or supposed to be parallel, to CD, and remember we marked parallel lines with arrows on them. I don't think I had the drawing tool able to get those arrows on there for me when I printed this. What this means is that if you have parallel lines and a line that cuts through the parallel lines, which is known as a transversal, the word trans means to cut or to cross something, so that line PQ is crossing over the two parallel lines. What that says is if you've got an angle on the same side, or two angles on the same side of your transversal and on the same side of your parallel line. So this angle W is above the parallel line and angle X is above the other parallel line, but they're also to the left of the transversal line. So if you have the same corresponding angle, the angle in the same corresponding type of position, those angles will be equal to each other. So in this diagram, W will actually equal X. Now, some of you will know this as your friend, the F pattern. So let me just grab a highlighter here. This traces out a capital letter F. So I'm trying to highlight here. There's the stick of my F, and here's my two little stems. So that sometimes helps people remember that these angles inside that F pattern are going to be equivalent. So I'd like you to try and use that to help you get angle Y, for example, in the example. And then you can use some other theorems that you know from the previous part of this video to help you get angle W and or angle X, okay, in the diagram on the example. Okay, the second part of the parallel line theorems is this one called the alternate angles. This is lovingly also known as the Z pattern. So these are the ones, if you can count out or trace out a Z pattern on your parallel lines, you have angles that are also equal to each other. So let me get the highlighter again. If I were to trace out a letter Z here, what that tells me is that the angle in the crook of the Z here would be equivalent to the angle here in the crook of the Z. Okay, or I could, let me get an eraser tool here, I could redraw that and I could trace my Z out backwards. And what that means then is this angle W here would be equivalent up here in this corner. So I'm going to just mark that in with my pen. If this is angle W, that will equal angle W here. If this is angle X, let's say, in this corner, then in this corner, this would be angle X as well. So these are the Z pattern or alternate angles. Use that here to help you solve for some angles. See if you can use the Z pattern or the alternate angle theorem for our example. And then you can use some other theorems that we've already covered to help you get some of the other angles. Be sure you know how to justify your answer. So did you use an F pattern? Did you use Z pattern? Did you use opposite angles? Did you use the fact that you had a straight line or supplementary angle? You should be able to justify that. The last parallel line theorem is co-interior angles. So these angles are also inside the parallel lines, but they're on the same side of the transversal this time, not alternating. So this is also known as our C pattern. Now these ones are not equal to each other. This is a little bit different here. What we have instead is that these angles are going to add up to be 180 degrees. So if I call that one X and this one Y, okay, X and Y, we're going to have X plus Y has to equal 180 degrees. And that should make sense because down here this would be an angle X by the F pattern, or the corresponding angles, and then we have a straight line, and X plus Y, because they're on a straight line, would have to equal to 180 degrees. So different ways to get there, but when you have parallel lines and you can create that C, the interior angles on the same side of the transversal equal each other. You try and use that theorem somewhere here first in the example diagram, and then you can use other information to help you solve for the remaining angles there.